Okay, evaluating logs without a calculator. Again, I'm just going to keep hammering this point that being able to do this will help you understand logarithms better when we get into some of the other uh, crazy stuff that we're going to do. So, a logarithm, okay? I'm just going to keep writing this in case this is the first time you've seen it, okay? A logarithm is an exponent. Okay, or r. I say logarithms are exponents. A logarithm is an exponent. And when we use the word is, okay, in math class, a lot of times that means equals. So this logarithm is an exponent. It's a number, okay? This has one value. This entire package has one value. The value that I have here, I don't know. Now they're not going to put a variable here, but if you want to put a variable here, that's okay for now, because at this point you've seen some examples of how to write logarithmic form in exponential form and vice versa. So if we think of it like this, log base 2 of 64 is equal to x, and I don't know what this is, then I can convert this into exponential form, which would be the base of the log. Again, something I say quite a bit. The base of the log, if you haven't written this in your notes yet, you should. The base of the log is the base of the exponent. Okay. So when I convert between the two of these, I can take the base that's in this log, make it a base for x, and set that equal to 64. So one way you can do this is to understand that a logarithm can be written in exponential form, and then once it's written in exponential form, there's no shame in guessing and checking here, right? So we know you should know your first few powers of 2. You should know that, excuse me, 2 cubed is 8, which means 2 to the 4th is 16, which means 2 to the 5th is 32, right? I just keep multiplying by 2 here. 8 times 2 is 16, 16 times 2 is 32. If I multiply this times 2 again, that'd be the 6th power, which is 64. So this number is a 6, right? Which means the value of this logarithm is a 6. So there's value in understanding how to write a logarithm in exponential form, okay? Because if you're ever doing this without a calculator and understanding that, yes, we can use calculators in our current situation, but if you take that calculator away, understanding that a logarithm is equal to a number, and that number is the power of this base that produces this number, there's definitely some value in realizing that. Okay, that's why we're practicing these problems.